Okay, so this is the schedule. So tonight we're doing a dry lab and a wet lab. Dry lab you're going to be doing at home. The wet lab, you're just like I was saying before, you're just doing the data part. Do the reaction, observe. Okay, so our next test is set up for the middle of November, which is a ways off. Okay. Now tonight we're going to get into something called stoichiometry, and that's the base of Unit 4, stoichiometry. Stoichiometry is the quantitative relationship between the reactants and products. Quantitative, that means numbers. And we're going to be using these 4 steps again. So if there's a chemical reaction, you need to balance that chemical reaction. Okay. Now, in this class, I'm always going to give you the reaction and assume it's always unbalanced. So always check, see if it's balanced or not. In 1A, you're going to have to read the paragraph and figure out what the reaction is, then balance it. So step number 1 is balance the equation. If you balance it incorrectly, guess what? The whole rest of the problem is going to be wrong. So that's why balancing equations is crucial. And then we do the normal step. What's given, what are you trying to calculate, and then do the setup. Now there's a couple more conversion factors. Some of these you've already talked about. Avogadro's number, 6.02 times 10 to the 23rd. Atoms or molecules. In a mole, molar mass comes from the periodic table. That's the decimal number. One we haven't talked about yet is the molar gas volume at standard temperature and pressure. Now, this is crucial that it's at standard temperature and pressure, STP, because gases are compressible. So you can't judge the volume unless it's at standard conditions. And that's 1 atmosphere and 273 Kelvin temperature. Okay, so that's the new one, okay? And that applies to all gases, regardless, whether it's uranium hexafluoride, extremely heavy gas, which they make weaponized uranium into bombs out of, or helium, the lightest gas. Actually, hydrogen is the lighter gas. Hydrogen and helium are really close. Okay, so we're going to be using these conversion factors for the rest of the unit, and actually into Unit 5 as well. So let's look at a typical stoichiometry problem. 15 grams of methane, CH4, burns in oxygen to produce water and carbon dioxide. How much water is produced? Now, in Unit 1, we didn't do any chemistry. It was just there's this, what do you got? I change it into something else. But there's no chemistry going on. Here we have chemistry, because what's given is methane. What you're calculating is carbon dioxide. So you've got to go through a chemical process to go from the methane to carbon dioxide. And that's the reason why you balance the equation also. So step number 1. All of you should know that this is not balanced the way it's written. Because remember, I had you all learn this combustion of methane. So when we go to balance it, We know it's balanced because the CHOs are equal on both the reactants and the product side. Okay, so step number one is boom, got it done. Okay, so now we go into step number two, which is what's given. Given is what are we trying to make? Oops. We're trying to calculate the water. So water is going to be on the far right. Okay, so given is 15 grams of methane, trying to calculate how much water is there, how much means in grams. And then the next thing is the setup. So we need to figure out how to go from methane to water. That's where the balanced equation comes in. Remember, we talked on Thursday, week ago Thursday, that there are two things that you can say from the balanced equation. It's a molar relationship and it's a molecular relationship. So the molar relationship is where we're going to get this transition from methane to water. It's through the balanced equation. Okay, grams is not moles, so we need to convert the methane here into moles. So we're going to use the molar mass from the periodic table. We need to know how many grams are in 1 mole of methane. So carbon is 1201, and we have 4 hydrogens at 101 apiece. Okay, so that's going to be 1604 grams. Okay, so now grams cancel. Yeah. It's 1605, everyone. Okay, so now we have moles of methane. How do we go from moles of methane to moles of water? That's through the balanced equation. And we're looking at the coefficients. These numbers right here. So it's 1, 2, 1, 2. Okay, so the methane needs to cancel. So that means methane is going to be the bottom here. It's going to cancel. On the top, we want to put what we're trying to calculate. Is going to be water. So now we take the coefficient ratio. Okay, water is 2, methane is 1. So now we have moles of water. We want grams of water. So that's going to go from moles to grams. Bless you. So notice everything cancels except grams of water. That's what we're trying to calculate, grams of water. So make sure in the setup is on your paper that when you're canceling units, make sure everything cancels except what you're trying to calculate. If something is left over that you're not trying to calculate, the setup is wrong. And again, this is 90%. So multiplying everything on the top, dividing by everything on the bottom, we end up with 33.7 grams. 3 sig figs here, 4 here, infinite here, because we made it exactly 2 and exactly 1. There's no measurement here. So that means we don't, this ratio of the coefficients, you don't take the significant figures of that into account because it's infinite. And then 4 over here. So our answer is going to be 3 sig figs. Now I want to tell you something. Every single stoichiometry problem is going to fall into this format. You convert to moles first. Whatever it is, if it's grams, you convert to moles. If it's gaseous liters, you convert it to moles. If it's number of particles, convert it to moles. Because now we can employ a molar relationship from the balanced equation. Remember, it only works for moles and molecules. And then we convert to what we're trying to calculate here, whether it be grams, liters of gas, or number of particles. Now, on Tuesday, we're going to jack this up big time. This is the simplest it gets for stoichiometry. On Tuesday, we're going to have 2 givens. So you're going to end up doing 1 calculation, going to 4 calculations for that 1 problem. So it's imperative that you understand this for Tuesday. It's real important for Tuesday. It's called 2 givens, and they're usually reactants. What product do you get? Okay, are there any questions about this? This makes sense? Again, it's mole relationships. Okay, so let's balance this from before. 28 grams of carbon dioxide is produced. How much oxygen is consumed? Again, how much means grams. So we're going to start with 29 grams. Notice this is on the right side, but it's because it's given, we still put it on the left. It doesn't matter where it lies in the reaction itself, the equation. Whatever's given goes on the left. Whatever we're trying to calculate goes on the right. And we want to calculate grams of oxygen. Okay, so first thing we do is convert to moles. That's going to be 1201. Okay, so now we have moles of carbon dioxide. Now we need the ratio from the balanced equation, where carbon dioxide's got to cancel, so it's got to be on the bottom. Water's on the top. Well, excuse me, oxygen's on the top. And that's going to be 2 to 1. And then oxygen moles, we need to convert to oxygen grams. So that's and oxygen is 16, and there are 2 of them. Now I want you to look at this and that. The setup is exactly the same. So if we produce 29 grams of carbon dioxide, we're going to consume 42 grams of oxygen to get that. Is this making sense? Reasonable? And let's do something with gases now. Okay, given 23.4 liters of oxygen, if all the oxygen is consumed, 23.4 liters of it, how much methane is required to burn that much? Or how much methane is used up? So now we got to get liters. Are we going to get liters into moles? What conversion factor are we going to use? Exactly. Right. Okay. Now we have moles of oxygen based on its volume, 23.4. Okay, so now we need to convert the oxygen over to moles of oxygen over to moles of methane. So now we have moles of methane. Now we need to convert the moles of methane to grams of methane. So again, it's if in doubt, convert to moles. Moles, moles, moles in chemistry. Okay, given is 5 grams of water, how much is 5 grams of water is produced? How much oxygen is consumed? And water is going to be our grams cancel. Now we need to go from water to oxygen. And then oxygen is 32. Sorry. Yes, I should have used the 22.4 instead of grams. I was So we're using up 6.22 liters of oxygen. Okay, notice the water cancels as well. Again, I want to emphasize this. It's basically three parts. Part one is taking the given and converting it to moles. The middle step is taking the calculated coefficient over the given coefficient from the balanced equation. The last step is taking the moles of what you're calculating to whatever you're asked to calculate. Always the three steps. I want to keep emphasizing this. Same three steps. So I'm giving you all these examples, they're all the same thing. Again, it's crucial you understand this process. I'm going to give you a little hint of what Tuesday is going to be like. Just another problem again. Balance equation first. 23 liters of methane is given. We want to know liters of oxygen. Now, can anyone see a shortcut on doing this problem? Exactly. Yeah, we have 22 on 4 on the bottom, 24 on top. It's a fraction. So those cancel. So that's the same as 1. So really, all we need to do in this one is multiply two times 23.7. So that's what? 47.4 liters. Now, you can put that in your calculator if you like. And you'll get the same answer. Okay, so that is simple stoichiometry. These are as simple as it gets. Okay, why don't you try doing this one on your own? I've even pre-balanced it for you. Necesitas mucho práctica. Is this making sense? There's lots of practice. But after a while, you'll see it's the same thing. 3 parts every single time. It's making sense. That's making sense. Why is it green? Huh?
Green tea.
Oh, just wondering. Don't forget I have a video. Yes.
That's the wrong answer, so. I think balance, it's 20.
No, it's 22.4. Here, you mean? That's the conversion to go from liters of gas to moles of gas. Oh, actually, Is this what you got?
Yes.
I know in mine, I was just looking over mine.
Hey, actually, 'cause I did it again.
I was
my
dividing by
crazy.
2.4 instead of 22.4.
Okay. Ew.
I'm glad you mentioned that. And it's nice on my calculator, you can go up and you can
Yeah.
see the setup and everything.
I mean, I guess mine.
The red one. I like red stuff, so I have a black one and a red one. And I lost my black one. Of course, whenever you lose anything and buy another one, you immediately find the one that you lost.
Yes.
So guess what? Showed up. My old black one, so.
Hey, that always sense when it like your ID or your keys or something.
Oh,
Making
yeah.
copies of everything. And then you find it better and better.
Problem is you have to get the DMV illegally. Because you don't have your license.
Yeah, heck. Yeah, true.
Actually, you know what you should do is keep a picture of your driver's license
I do have
in
one
your
now.
car or something like
Oh,
that.
that's smart, like print it out.
And if a cop stops you, just say I'm on the way to the DMV. Because otherwise, they give you a fix-it ticket. Driving without. Oh, no, really, really.
You need to get- I want to make sure.
It's not as bad as not having one. It's just not in your possession or something like that. So,
Things like.
but fines are like,
And the mean ones is the fact that house. Around.
it's expensive now to get your headlights replaced.
Yeah, that's why I have to find it.
Yeah. Okay, did everyone get the same answer as me the second time? Yeah, I divided by 2.4 instead of 22.4 when I was hitting the keys. The two twos didn't come through. Okay, well, that's the guts of what I wanted to cover today because I'm going to show you what's coming on Tuesday. Okay, and you don't have to copy this down what I'm going to do in a minute here. But I wanted to give you a harbinger of what's going to come for Tuesday and why it's germane for you to learn this simple setup. Because on Tuesday, it's not going to be a simple setup. It's going to be a half page of calculations. All right, so. Okay. Two givens. Two givens. The problem is, which one do we use, or do you use both of them? Now, let me give you an example of this. Okay, if I've got 10 bicycle frames and 10 wheels, how many bicycles can I make? 5. How'd you get that? Each frame requires 2 wheels. That means we don't have enough wheels to go around. So what's limiting the amount of bicycles we can make? The wheels or the frames? Wheels. So the two givens here are wheels and frames. And in your mind, you went one frame equals 1 bicycle. That means I can make 10 bicycles. 10 wheels, 5 bicycles. So the wheels are limiting the reaction, not the frames. Same up here. What limits the amount of product? Okay, the methane or the oxygen. So that means just like you did 2 calculations in your head on calculating the frames, bicycles, wheels, bicycle, we're gonna have to do 2 calculations here as well. And then how much is left over of the one that we had too much of? It's another calculation. And then there's one more simple calculation. There's 4 calculations for this problem. Now, this is what we're going to go to in detail on Tuesday. But just let me show you how to work this. And all I want you to do is just observe, and you'll see why it's imperative you need to learn the simple stoichiometry we did today for Tuesday. So let's just pick one. Of course, the reaction equation, we have to, of course, balance that. Okay, so that's our equation, and it's balanced. So the next thing we're going to do is do a setup. So let's just choose one. It's totally arbitrary which one you choose first. So let's just choose the methane. We want to see how much water just the methane by itself will make. We want water over here. Okay, gee, does that look familiar? Okay, doing this calculation, I'll figure out how much, if I was just looking at the methane, the 29 grams of methane, how much water would I make? Okay, so we're going to go, yeah,
You're gonna do this stuff balance, but you have to balance and do both flows.
balance first, all the time.
We're gonna balance and then later do this.
Yeah, yeah.
Okay.
So there's, before you came in, I gave the 4 steps for stoichiometry. First step is balance the equation. What's given? What are we trying to calculate? Then the setup. So step number 1 is always balance the equation. Because this middle step here requires a balance equation. Okay, so if we're just looking at the methane, it'd be 65.1 grams. Okay, so now let's do the same thing, only looking at the oxygen. And Okay, so if we're just looking at oxygen, it only makes 6 and change grams of water. We just were looking at the methane, gonna make 65. So what's limiting the reaction here? The oxygen or the methane? Oxygen. It limits because we don't have enough oxygen to go around for all that methane we have. So that means that's the limiting reactant. Now the next question is, how much methane do we have left over? Because we're going to totally consume all the oxygen. The limiting reaction gets totally consumed. The other one is in excess. So how much do we have left over? Okay, well, first step is to calculate if we use 12 grams of oxygen, how much methane are we going to produce or consume? So we're only going to use 3 grams of the oxygen, of the methane. But we started with 29. So the fourth calculation is going to be how much is left over. So we started with 29. This is grams of methane. We used 301. So that is a typical limiting reactant problem. So notice what we're doing today, we did 3 times. That's why it's really important to get this idea down of how to do the simple stoichiometry. Because on Tuesday, we're going to be using it a lot. Okay, so that, yeah.
If we're trying to calculate how much water was produced, then we just add together the 65.1.
No, we produce 6.76 oxygen.
H2O. It did the first calculation.
Okay, wait a minute.
I think I'm just confused, but I'll get a better explanation Tuesday.
Re-ask your original question.
Trying to figure out how much water was produced from the reaction. Would you add together 65.1 grams and 6.76 grams?
Okay, let's go back to the bicycles. Okay, 10 frames, 10 wheels.
Yeah.
How many bicycles do we make? 5. The number of frames don't come into play because the wheels limited the number of bicycles.
Okay,
So that's why you don't add them together.
because only the limiting reaction
Counts. Yeah.
Okay.
But we're going to use a little bit of the other stuff. And then how much of it did we use? That's the third calculation.
Got it.
And then that's how much we use. Then we subtract that from what we started with. And that's what's excess.
Got it.
Better?
Yeah. Maybe understand it.
Okay, so that's it for today. I have a ton of practice besides your book. I have a ton of practice under files on Canvas. In fact, let me just show you. Huh? The files?
Yeah.
What? Go to stoichiometry under files. And there's equation balancing here. There's early stoichiometry, which is the ones you're doing today. There's limiting reactants, all kinds of practice here. There's really a lot of practice. Huh? Yeah.
You're gonna be performing the lab today. It's gonna be like us over you.
No, both.
Oh,
I have 2 demos and then you're going to do the rest.
okay.
It's really easy today. You go drop, drop, observe, drop, drop, observe.
Oh,
And then in unit 5, we'll get to all the little details.
so just